As we'll see, it turns out that this formula for a tangent slope is useful in lots of contexts other than just finding the slope of a tangent line. So we're going to give this expression a name that sort of divorces it from its origin as just the slope of a tangent line. And what we're going to call it is a derivative. So for this expression, we will call this the derivative of f of x at the x value a. And we're going to write it like this. So f with a little apostrophe or a prime symbol. And then we're writing it as if it's a function, so with a here. So for this clump of symbols, you read f prime of a, or f prime at a. But this is just the same formula as for the slope of a tangent line at a. So it's not a different formula, it's just a different name for it, really. So for example, if we have this function x squared minus 2x plus 3, let's find f prime of minus 2. Well, f prime of minus 2, it's just this same formula, limit as h goes to 0 of f of, this minus 2 here is playing the role of a. So a plus h, so that's minus 2 plus h, minus f of a, which is minus 2, over h. And then we just need to evaluate this limit. So as usual, if you just plug in 0, you get 0 over 0, so we have some algebra to do. So limit as h goes to 0, f of minus 2 plus h. So we need right here for x, we have to plug in minus 2 plus h. And remember your parentheses, right? This minus 2 plus h, this is a single chunk that we're plugging in here. So the whole thing gets squared. So don't forget your parentheses or else things are going to start going wrong. Minus 2 times that same chunk, so minus 2 plus h, plus 3. So this whole piece here is f of minus 2 plus h. So now we need to subtract f of minus 2. So that's, right? And we're subtracting this whole chunk here. So we need parentheses. F of minus 2 is minus 2 squared minus 2 times x, which is minus 2, plus 3, all over h. Okay, now we have a ton of algebra to do. We're going to simplify the numerator. Hopefully there will be a common factor of h. In fact, we sort of know ahead of time that the graph of this is a parabola, so it will have a tangent line, so this limit should be defined. So we kind of know ahead of time that this limit should exist, and so the numerator should have a common factor of h. If you simplify this sort of thing and you find that the h in the denominator doesn't cancel, that's usually an indication that you made some sort of algebra mistake, so then you can go find your algebra mistake. Okay, so limit as h goes to 0, we better multiply all this stuff out. Minus 2 plus h squared, that's 4 minus 4h plus h squared. Now we need to distribute this minus 2, so plus 4 minus 2h, and then plus 3. And then we also need to distribute this minus sign here, so minus 4, because minus 2 squared is positive 4, but then hit it with that minus sign. And then, so this is plus 4, but then with the extra minus 4, it's, with the extra minus sign, it's minus 4, and then minus 3. Okay, all over h. And now we can go looking for things that cancel. It looks like, let's see, this 4 can cancel that 4. This 3 can cancel that 3. This 4 can cancel that 4. And now it looks like we're good, because everything in the numerator has a common factor of h. So let's see, the pieces remaining in the numerator are this piece, this h squared piece, and this minus 2h piece. So this is minus 6h plus h squared. And when we factor an h out, we get h times minus 6 plus h, all over h. Now we can cancel the h. The stuff that's remaining is a polynomial, which we know polynomials are continuous everywhere, so now we can just plug in 0. And we get minus 6. And we're done. So this was, again, this was f prime of minus 2. All right, so for this particular example, we kind of knew ahead of time that since this is a parabola, it should have a tangent line everywhere, and in particular at this x value, and that tangent line will have a certain slope, and so this limit should exist. But what if that doesn't happen? What if you don't have a nice tangent line? So let's look at an example where a derivative doesn't exist. So let's try to find f prime of 0 for this function, the absolute value function. Now, even before we do a calculation, this should seem kind of suspicious because at x equals 0, what would you say the tangent line is for this function? I mean, is it like this? Is it like that? Is it like this? Is it like that? It's not really clear what the tangent line should be. So it's not really clear what the derivative at 0 should be either. But let's see what happens when we just try to calculate this derivative. So f prime of 0, that would be the limit as h goes to 0 of f of 0 plus h. Remember this 0 right here, this one right here, that's playing the role of a. So we have a plus h here, so it's 0 plus h, minus f of a, which is 0, over h. Okay, so limit as h goes to 0, our denominator is just h. In the numerator, 0 plus h is just h. And f is the function that just takes the absolute value. So f of 0 plus h, that's just the absolute value of h. And then minus f of 0, well, the absolute value of 0 is 0. Right? So we don't really need this minus 0 part. That doesn't change anything. So we need to find the limit as h goes to 0 of the absolute value of h over h. And this limit is a little tricky because, well, because of the absolute value. The absolute value, we can interpret this as a multi-part function. The absolute value of h is h if h is positive, and it's minus h if h is negative. And when you have a multi-part function, remember calculating limits, usually you need to do the limit from each side separately and then see if the two limits agree. So let's do the limit as h goes to 0 from the right of absolute value of h over h. So in this case, since we're taking the limit from the right, h is positive because it's to the right of 0. And when h is positive, the absolute value of h is just h. And now we have h over h. Now we can simplify this stuff. It's just 1. And the limit of 1 is 1. So the limit from the the limit from the right is plus 1. Now let's do the limit from the left. So limit as h goes to 0 from the left of the absolute value of h over h. Well, for this limit, since we're to the left of 0, these h values are actually negative. So for negative h values, the absolute value of h is actually the negative of h. Right? H itself is negative, and so negative h is positive. Okay, over h. And now when we simplify, we get limit as h goes to 0 from the left. Negative h over h is minus 1, and so this limit is minus 1. So we see that these two one-sided limits don't agree. So the two-sided limit as h goes to 0 of absolute value of h over h, does not exist. Okay, but this limit was f prime of 0. So that means that f prime of 0 doesn't exist. So if we go back to the original question, find f prime of 0, well, there's no such thing. This just doesn't exist. So what is it about this function that made that happen? Well, it was exactly this ambiguity about what the tangent line should be. Remember at the beginning we said we didn't know what the tangent line is, and the fact that this derivative doesn't exist is kind of telling us that there is no good tangent line here. In fact, you can see that the one-sided limits, 1 and minus 1, well, the tangent line coming from the right-hand side has slope 1, and the tangent line coming from the left-hand side has slope minus 1. So that's why we got these two different values for the one-sided limit. But since there's no single tangent line, there's no single value for this limit, we'll say that the derivative just doesn't exist. And for this graph, the reason that this happened is because there's a sharp corner here. Right? It's the sharp corner that allows there to be different tangent lines coming from each side. The other examples that we've looked at with slopes of tangent lines have been nice, smoothly bending curves. And when you have a nice, smoothly bending curve like this, there isn't room for more than one tangent line. There's a single tangent line. And in this kind of situation, this limit that gives us the derivative would exist. So it's really the sharp corner that makes it so this derivative doesn't exist.